Hi, hello. Thanks so much for joining. I appreciate you guys coming to this session over all the other wonderful sessions that are going on. My name is Grace Jansen. Don't let the name fool you. I speak no Dutch, I'm afraid. My grandpa is Dutch, but he didn't pass any of it on. Rubbish. So I'm afraid I speak nothing except having the surname. But yeah, so I work in the UK, if you can't already tell from the accent. And I work in the IBM labs there, mostly looking at cloud-native technologies around Java and sort of open source projects in that area. A little bit about me. Before I joined IBM, I did a biology degree specializing in fish. So that's been super helpful in my career so far. If you guys want to chat to me about that, I'd be happy to in happy hour. But yeah, today I'm not focusing on fish. You'll be glad to know I'm focusing on observability. So looking at how we can develop effective observability in our cloud-native applications. Now, I've chosen this title deliberately. Does anyone know where the phrase "through the looking glass" comes from? I'll buy you a drink in happy hour. Yes, yeah, perfect. Alice in Wonderland, great. So yeah, this is where the phrase originally came from, is the sequel to the book Alice in Wonderland. And you might have seen sort of the relatively recent Disney movie that came out. It's all about what happens in the film or the book, if you've not read or seen it, is it's about Alice stepping through this looking glass or mirror to be able to enter once more into Wonderland. So it kind of acts as this analogy of stepping through and seeing a world that we weren't previously able to see. It's kind of having our eyes opened. And this analogy is also used in other media and other movies. So does anyone recognize this movie before I press play for the meme? Any points? You'd have to be a real big fan, I think. Yes! Top marks. So yeah, it's actually used in The Matrix. So if we think back right to the beginning of the film, when Neo first gets the message on his computer, when he gets woken up, it says to follow the white rabbit. So it's that theme back to Alice in Wonderland again. And also at the end of in the film, when he gets offered the red or the blue pill, they say, you take the blue pill, the story ends, and you wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. So this analogy of stepping through mirrors, stepping through portals, is used time and time again, and that's essentially what we're trying to achieve when it comes to observability. We've moved from having our applications running locally, where we can easily monitor and troubleshoot and understand what's going on within our application, into this world of the cloud, and it's suddenly distributed, and we're not quite sure what's going on or how our application is behaving. And this is the difficulty. So what we're trying to achieve is creating this sort of portal that we can step through to actually understand what's going on within our applications. So now that I've painted that great picture, hopefully I'm going to show you how to do it in this presentation. So this is the agenda today. So we're going to be taking a look at why we need observability, what I mean by this term observability, because sometimes these terms can be quite broad and cover a lot of different things. So I'm going to set that expectation with sort of a definition right at the start. Then we're going to take a look at how we can do it, looking specifically at OpenTelemetry and an implementation of that in MicroProfile. And of course, we're software developers, so we want to see code. So there will be a live demo towards the end, so I will show that as well. And then, as if I don't set enough links and homework throughout this presentation, if you want more, there's a whole resources slide, so you can look forward to that at the end. Okay, so the first step, why do we need observability? Why are we interested in this in the first place? I've kind of touched on this a bit already, but it kind of stems from the fact that our infrastructure and our applications have evolved over time to increasing complexity. So we've moved from where we used to have, for example, single cores. We're now using multi-threading, multiple cores. We've got containerization, virtualization in our underlying infrastructure. And our applications have moved from more sort of larger monolithic applications into these sort of distributed microservice-based applications. And with that adds complexity. So why do we do it? Why do we bother moving to the cloud? And I think, I'm not going to stop using this slide. I use it in most of my presentations because I love it. So if you've seen it before, there are no apologies. This is why. This movie is why. This feeling we get as developers of, ooh, the cloud. We get excited by the cloud because of the innovations and the behaviors that it allows us to be able to create and take advantage of within our applications. However, it doesn't always feel this exciting when we're actually developing in the cloud. What it can often feel like is a bit more like this. it can be frustrating, it can be annoying, and half the time stuff doesn't work and you don't know why. So actually trying to effectively troubleshoot your applications in the cloud can be a real big frustration, as Sheldon is showing. So what sort of we need to focus on in our applications when it comes to distributed nature of them is how we can check the overall health of our systems, how we can pinpoint and really find the root cause of potential issues, and how we can deal with those to be able to stop things like performance bottlenecks and to ensure our applications are performing at optimum as much as we can. And so this is where sort of this issue of being able to do this is coming up as a really important topical issue time and time again in things like methodologies, for example, of how to create effective cloud-native apps. So one you may or may not have heard of is the 12-factor app methodology. This has been expanded and developed into the 15-factor app methodology. And I've made your lives really easy because we're getting towards the end of the day. I've highlighted the 3 that have been added to make it super easy for you. So we've got API first, telemetry, and weirdly, what I thought was strange is there was no mention of security in the original 12 factors, which blew my mind. But a really important addition here of authentication and authorization. Now, the one I'm focusing on here, obviously, for this presentation is telemetry. So this is really highlighting the importance of the fact that we're recognizing that as this infrastructure and our applications are becoming more complex, it's becoming ever more important that we consider this as an important element when creating effective cloud-native apps. And that's really because it enables lots of the behaviors I described before, better performance, better reliability, being able to pinpoint the sort of bottlenecks or the failure points or the issues that are happening within our applications. So it is a very, very important issue, and hopefully I've now convinced you of that, and we can move on from the why. Perfect. So now on to the what. So what do I mean by observability? I'm just going to whiz over this quickly, just so we're all on the same page here with what I'm talking about in this presentation. So there is obviously the general definition. Here is the general one, which is basically about understanding the internal state based on external outputs. It's kind of putting it simply. But we don't really, and this kind of definition, this phrase observability comes from control theory, which is all about sort of being able to, it's like an area of engineering that's concerned with automating the control of a dynamic system. So if you think of water through a pipe or an automobile going down declines or inclines, it's this sort of engineering and physics is where this definition comes from. But we're software developers. We want to know how it relates to us. General definitions aren't always helpful. So I've tried to come up with sort of a specific IT and cloud computing definition, and I've highlighted the key aspects that I wanted you guys to focus in on. So really what I mean by observability is gathering, correlating, and analyzing a stream of data to be able to monitor, troubleshoot, and debug our application. Those are the key terms we're looking at here in terms of what I mean by observability. So hopefully we're all now on the same page, and we know roughly what we're trying to achieve here. So now that we know what we're trying to achieve, it's the how that we're always interested in. So how do we actually go about implementing this in our own applications? Conceptually, this is actually fairly simple. It's when it comes to practically implementing it that it can become a bit more challenging and difficult. So when we're looking at it conceptually, there are, in my opinion, 3 main steps that we need to go through. The first is instrumentation. So we need to be able to make sure that our apps are able to actually are instrumented in a way where we can get data out of them, because without the data, we aren't going to be monitoring much. So we need to be collecting key relevant data that can include metrics, traces, and logs, and we'll go into those in a bit more detail in a minute. The second step is we need to send that data somewhere. So we need to be able to send it somewhere that can store and analyze it. For this, you might be using tools like, for example, Jaeger, Zipkin, Autocollector, whatever it might be, lots of different tools out there that you can utilize. And then the third step is, okay, now that we've collected it and we've analyzed it, how can I now understand those trends? So providing visualization and insights into that data is that third important step. And all of these are vital in terms of actually not only collecting that data, but also understanding that data and being able to act on it. Now, for this last one, you might be using systems like, for example, Prometheus, you might be using Grafana, Kibana, whatever it is. Again, a plethora of tools you can make use of. So in this presentation, I'm not focusing on number 2 and 3. I'm just focusing on this first step, instrumentation. So how can we enable instrumentation in our application? Because once you've got the instrumentation, you can then start plugging into those external, often open source tools to make use of the storing, analyzing, and visualization. So when it comes to instrumentation, there are 3 key pillars that are utilized within the industry, and that's logs, metrics, and distributed traces. Now, there are obviously other sources of providing sort of data from our applications for us to be able to utilize. And it is hoped that in the future, these will be added to existing platforms and tools, like, for example, OpenTelemetry. These can include things like end-user monitoring and profiling. So really looking at how our end users are utilizing our application, what paths they're taking, how long they're spending on each individual thing, or profiling, sort of looking at understanding our memory and CPU utilization, understanding resource utilization, even down to the level of what line of code is blocking me or taking the most utilization, how can I make that more efficient and effective? So it is hoped that these will be integrated in, but currently it's mostly just these 3 core pillars, and they're the ones we're going to be focusing on today. So first one is logs. Now, we're at JSpring, so you guys are already software developers, so I'm expecting that you're already fairly familiar with logs, so I'm not going to spend too much time on this. But essentially, logs, we're already using in our software applications. They're a great way to be able to get a message for a particular thing that may or may not have happened but might have gone wrong, for example, at a particular timestamp. So at a particular point in time, what's happened with our application. They can be useful in terms of providing sort of higher level information, but they're not usually particularly detailed. And the main limitation, I would say, with just using logs and nothing else is that it doesn't give us any information about the particular user request, for example, or the particular transaction that's occurred in which that log was created. So it doesn't really give us much context, is the main issue here. So what we add on top of logs is often metrics. So metrics are a very useful numerical form of data that we can use to be able to we can transform this data. That's the benefit of it. Being able to transform it in a mathematical, problematic, statistical manner so we can start to understand how our application is behaving over time, not just at a specific time stamp. So this can really help us to understand things like system error rates, CPU utilization, request rates, for example. So getting a broader idea of how our application is behaving, is it healthy, is it how we expected? However, again, the issue with metrics is it's not as fine-grained as we might like. It might tell us that we've got a lot of system error rates, but it doesn't necessarily help us pinpoint exactly where in our application things are going wrong or where our bottleneck is. It doesn't provide enough specifics or context for us to be able to determine that in such a distributed system. And so that's where we introduce distributed traces. However, metrics are still helpful, and it's a combination of these that is really going to be helping us to create effective observability. So if you aren't already using metrics and you want to use metrics, then you can always use MicroProfile. So are people familiar with MicroProfile? See a hand raise. Quite a few hands. Okay, there's some hands missing. So just to give you a bit of a sort of general introduction to it, this is a community-driven specification for Java EE and Jakarta EE applications. It was designed and it's developed by the community, a range of different vendors and individuals. And it offers these different APIs as a specification to allow you to have effective microservice-based applications while still using Java or Jakarta. You'll notice that the bottom line here, if you're familiar with Jakarta EE, which is another community-driven specification, lots of these APIs are shared with Jakarta EE. So things like, for example, CDI, JAX-RS, JSON-B, JSON-P. So these are shared APIs. And then we have additional APIs on top of this, like, for example, the integrate layer and the observability layer. And in that observability, you'll see metrics. You'll also see OpenTelemetry, but don't look at that yet. We'll get on to that. So metrics is the one that we're focusing on. The nice thing with MicroProfile is that because it's an open source standard and an open source specification, there is no vendor lock-in. So there's lots of different compatible runtimes that you can make use of. And if, for example, you want that flexibility that comes with the cloud, you could potentially change between different application servers or different runtimes, depending on your application, your needs, without having to change the core part of your application, because the specification is shared amongst all of these implementations. If you want to find out, this list is always changing, as you can imagine, as new versions come out. So head to MicroProfile Compatible for the latest. But this, as far as I'm aware, should be the most up-to-date table of what is offered by each runtime. But essentially, the MicroProfile Metrics offers essentially that standardization. So a way to be able to export monitoring data to be able to understand how our applications are behaving and expose them as telemetry data. So that's metrics, and if you're interested, we have a guide that offers you sort of an intro to MicroProfile Metrics if you do want to give that a go. I'm going to be doing a guide on telemetry, but it uses the same system, so hopefully it'll give you an introduction to how you can get started with this. Okay, so as I said, that moves me on to distributed traces. So this is the point where we start getting more fine-grained, and we start to be able to pinpoint where things might be going wrong or where we might have potential bottlenecks or large resource usage within our application. Distributed traces allow us to be able to map the path taken by requests as they disseminate through multi-service architecture. So this is particularly useful when we're utilizing microservice-based architecture. Without tracing, it can be really challenging to be able to find the cause of performance issues in a distributed system. So it basically helps us to improve the visibility within our application, which is obviously important when we're trying to create that portal to be able to step into this world of the cloud-native apps. Now, I'm going to be showing a demo on tracing, so just in case people haven't come across tracing sort of key words or components, I've got some definitions here just to quickly whiz through so that I can start the demo and everyone's on the same page. I remember when I started working at IBM and I came directly from biology, it was like people were speaking Latin. Every other word was like an acronym or something I didn't understand. So bear with me if you're already a tracing expert. I'm just going to whiz through these quickly. So the first thing is a trace. Kind of obvious. So traces are important in tracing because they essentially they represent requests that span through multiple different microservices, and they consist of multiple spans. So you can see in my image here on the right-hand side, I've got multiple different microservices. I've got HTTP requests going between them. Each one has a particular span, and those spans form the trace. Spans are essentially single operations in a request. So a span usually contains things like metadata like a name, log messages, additional metadata, time-related data, that kind of thing, to be able to help us understand what's going on. Now, the important part that tracing also adds is context. So context is an immutable object that is contained within the span. It normally consists of two different values. One is the trace identifier. The trace identifier is basically the unique identifier that we assign in the root span to be able to follow through all the spans and have them all related to the same trace. So you can see the trace ID here of FEF676. The second component is the parent ID. What that allows us to figure out is essentially who was the span before me, so that we can trace back exactly the order in which this request went through the different microservices and the different spans. So this gives us a really detailed idea of precisely when something may have gone wrong or caused a potential bottleneck. So with these two values, for any given operation, it's possible to be able to determine the originating root service and to reconstruct all of the previous parent or ancestor services in the exact order that led to that particular operation. So again, really gaining high-level visibility here of the deep technical what is exactly happening within my distributed application. So that's where it kind of adds on top of what's offered within logs and metrics, and why really we should be using all three at least in our applications. So how do we go about utilizing tracing? Because with logs, we usually have integrated tools. With metrics, we can use things like MicroProfile Metrics, or often it's also offered by our cloud provider or by our runtime. But with tracing, we can utilize something called OpenTelemetry, which is what we're going to be showcasing today. So OpenTelemetry, what is it? Well, the reason this was invented is because really, in the past, when our code was instrumented, it would really vary because each observability backend had its own instrumentation libraries and agents, and we had to learn each individually, and if we swapped, it was a massive issue. So really, this was created as that standardization to be able to have a standardized format in which we can have this sort of pluggable architecture that enables us to be able to add technology protocols and formats easily without having to relearn a whole new technique or a whole new set of tools. It originated from sort of open census and open tracing. So these two projects were created originally to be able to sort of provide things like a vendor-neutral API for sending telemetry data, and also to provide a set of language-specific libraries. The issue with this is you kind of had to use them in conjunction, and there were some gaps in between. And the main issue is we still have two standards. Two standard does not make a standard. That's just two tools. So really, there wasn't still a standard. And so that's where OpenTelemetry came in, as really trying to make a single standard that we could all utilize that filled some of the holes, and not needing to have to use both projects, just to use a single project and to have a sort of single source of truth, if you like. So that's where it came from. It is a collection of tools, APIs, and SDKs. The important thing here to note is that OpenTelemetry, don't mistake it for a full observability backend. It does not do your end-to-end observability. That's not the point of it. Observability is meant to be, OpenTelemetry is meant to be utilized with tools like Jaeger or Zipkin or Prometheus or Grafana to be able to provide step 2 and step 3 that I showed earlier. OpenTelemetry is more about the instrumentation rather than necessarily like visualizations, for example. So it is not a full observability backend, something to note. The way it works is it looks a little bit like this. So we have sort of areas or parts of our application that we're collecting data from, whether that's our application itself and the microservices, or whether that's our infrastructure as well. So we're collecting that data into a central OpenTelemetry collector, and then within that we're doing things like batch processing, for example, if we want to, retries, and then we're sending that, we're exporting that data to whatever we want to. In this case, we've got some databases that we're making use of, so observability front ends and APIs, basically. Taking a deep dive into that OTel collector, this is what it looks like a bit. So we've got the receivers on the left-hand side. In the middle here is where we have basically what's happening to our data. So whether we're doing batch processing, whether we're filtering, we might have some retry information in there as well. So really the collector is there to basically provide a vendor-agnostic implementation of how to receive, process, and export our telemetry data. So it's really designed to be an export, to be sort of that standard. You might wonder why you would want to use something like the OpenTelemetry collector in this case, why you wouldn't just use the individual agents. And I would say that if you're just trying out and getting started with OpenTelemetry, you can just send your data directly from sort of your backend, and that's a great way to be able to get sort of value quickly because you can try it out. However, if you do want to do things like, for example, retries, if you want to offload the data quickly, the collector basically takes care of all of this in that vendor-agnostic manner. So it can be beneficial if you're not just trying out a basic demo application. So we would recommend that you do look into utilizing the OpenTelemetry collector if you are going to make use of this. So in order to make use of this, you can use MicroProfile Telemetry. So this is an implementation of OpenTelemetry. This is a brand new API that's been introduced only recently into MicroProfile in the latest version, which is MicroProfile 6. You can see it's the only new API that's been introduced in this one. As I said, it adopts OpenTelemetry tracing. The thing to note here is OpenTelemetry offers a lot of different sort of collection of different data. So it includes things like, there's like baggage, there's logs, metrics, traces, and there's a couple of others. Now, MicroProfile tracing only implements the tracing element of that. So it doesn't yet implement the logs or the metrics or things like baggage, etc. It's hoped that one day, hopefully soon, they'll be able to integrate more of the OpenTelemetry capabilities into MicroProfile. But right now, there are some complications because of the existing APIs within MicroProfile, like MicroProfile Metrics. So being able to combine those provides a bit more of a challenge. So right now, it's just MicroProfile tracing, and it is designed to be able to help you essentially enable these traces within your Java applications. There are 3 ways in which you can do this. So you've got automatic, manual, and agent. Automatic, so if you're already using Jakarta REST or MicroProfile REST client, you can automate this straight away, so it's fairly straightforward and easy to do, and I'll showcase that in the demo. Manual, so if, for example, you want to manually add traces, you can do this either with the annotation with span, or you can utilize via CDI injection. So if you're utilizing things like MicroProfile or Jakarta eCDI, then you can utilize this. There's also agent instrumentation, which allows you to use OpenTelemetry Java instrumentation to be able to gather that Java data without modification. So the application I'm going to show looks a little bit like this. It's kind of similar to that diagram I had earlier, where basically we've got requests and responses coming into our application. We've got 2 microservices, and we're providing some context and collecting that all through traces and spans. We are utilizing a back-end exporter, because again, this is not an end solution. This is not a full solution. So in this case, in our demo, we're utilizing Jaeger. So without further ado, demo time. For this, I'm utilizing OpenLiberty. So has anyone come across OpenLiberty? A few hands. Great. Excellent. More than I normally see, which is lovely. So if you've not, check out openliberty.io. It's our website. This is essentially a cloud-native runtime to really help you create effective cloud-native apps, and it's beneficial for all of these reasons. Kind of easy to write. We have something called dev mode. So if you've come across Quarkus, you might be familiar with hot reload. We have an equivalent function called dev mode, which listens out for file changes so you don't have to keep tearing down your application to immediately see your code changes. We've also got things like, obviously, an integration with different testing frameworks. And the nice thing is that it's modular. So you can plug in the different features that you need, and you don't need your application server to be huge and humongous when it doesn't need to be. So more effective for the cloud. This demo isn't yet available. I just managed to squeeze out the draft version of it in time to show you. Huzzah! But unfortunately, you guys can't utilize it yet. Hopefully, it'll be out in a couple of weeks. But as an alternative, we have this, which is a GitHub repo, which is based on the same thing, the same application. So you can still check it out here. It's just not the fully fledged guide that we're going to be producing. So if you do want to check that out, feel free to take a picture. Otherwise, I'm going to be posting my slides online after as well. You got the picture? Oh, lots of people with phones out. 3, 2, 1. Excellent. Nobody can be annoyed. Perfect. Okay. So I've got about a couple minutes left. Okay, I'm going to hope this works. Can you guys see this? Perfect. Stay, please. How's the text? Okay at the back or bigger? Bigger. Absolutely. Better? Yeah. Perfect. Okay. So I've already gone ahead and gotten this started because in the interest of time. So essentially, same diagram here. We've got 2 microservices, system and inventory. We use the same application in all of our guides. So if you want to go ahead and do the MicroProfile Metrics guide, you'll see the same application there to make it easier for you to utilize and learn the technology. So in this case, the system microservice is scraping system data every 15 seconds. The inventory microservice is storing a list of that system data, and we can access that via a REST endpoint. So in this case, I've already gone ahead and started up my two microservices using Liberty Dev Mode. So essentially, it's already listening out for my file changes here, and we know that it's working when we see this message. Liberty is running in dev mode. So I've started up system, and I've started up inventory, as you can see here. So now what I'm going to do is essentially make sure that I'm just going to skip all of this. Again, you can follow through this guide when it's published. Perfect, already done that. Cool. So in order to enable MicroProfile Telemetry, I firstly need to enable it in my server.xml. We've created these buttons to make it a bit easier for you to utilize, except mine's not working, so that's fine. We'll do it the manual way, no problem. This is where I find out that my 3G has stopped sharing with me. All right, bear with. My Wi-Fi has stopped. There I am. Okay. Hopefully now it will work for me. Otherwise, this is a little bit sad. There we go. Perfect. Okay. Yeah, there we go. Right, it's opened. So we have these buttons to make it a bit easier. So in here, what you'll see is, at the moment, we've got some basic features enabled. You can use this copy button to be able to easily copy in all of the code you'll need for that class. And all we're doing here is adding this MicroProfile Telemetry feature, as you can see here. Now, we need to do the same for the inventory service as we do for the system service. So I'm just going to go ahead and paste that in and save. Again, just adding in that MicroProfile Telemetry into this microservice. What we also need to do is enable MicroProfile config. So kind of weirdly, I'm not really sure why, but MicroProfile Telemetry is by default off, so we have to make it on. So in order to do that, we need to specify the OTel properties in a MicroProfile configuration file. So to do this, we're just going to use this touch command to be able to create a new MicroProfile config. This is for the system, so we can just open that up. It should be empty. Copy and paste in this configuration. Copy and paste in. No? It doesn't like it when I don't save, which is probably a good thing, to be fair. There we go. Okay, so in here we have, all we've done is just list the name of the microservice and change this OTel config property to be false so that we can enable tracing. And then all we do is we do the same thing for the other microservice. Open that up, copy and paste. There we go, save. So now what I can do is this curl command. So if I make this a bit larger so you can see, and do a clear, because that just does not look good. Cool, so I'm just going to do this curl command to essentially run the system and inventory services to be able to essentially trigger them so we can start to see the traces that we've automatically enabled. So this is that automatic implementation that I was talking about before. So now if I go to Jaeger, I already got this started just using a real basic Docker run command that's available in the Jaeger documentation. So if you want to go and check that out, it's the first page of the guide when you take a look at this guide when it's published, which is hopefully in a few weeks. So here we go. We can go to System, find traces, and we can see we've got a system here. I should also have inventory, which is probably, let's just check this is up and running. Yeah. Just check all of these are saved. Save, save, save. You can see actually when I'm saving, you can see that my OpenLiberty instance is automatically updating for any files that I essentially change or save. Let's try this again. See if it works. Cool, find traces. Nope. Okay, for some reason, it's decided not to find my inventory traces today, which is typical. But essentially, hopefully, what I've shown here is that in a few steps, just by enabling a config properties file and by enabling that feature within my XML file, that I've been able to automatically already create a trace where I can see additional information and start to get a bit more information about it. In the interest of time, I'm afraid I don't have time to show you the manual implementation, but that's essentially the next part where we start to add in, that's my dependencies in my POM, we start to add in things like the @span annotation method. So here we go. So we add in with span, and we add in things like span attribute to be able to manually add spans and traces into our application as well. This is all using MicroProfile. So I'm sorry that I didn't get time for that today. Cool. Play from current slide. So hopefully in that whiz-through tour, I showed you, with my passion and excitement about observability, that we are entering a world of increasing complexity, that's a hard word, but that effective observability can enable us to be able to have that critical monitoring and understanding of how our applications are behaving in real time through a combination of things like logs, metrics, and traces. And the nice thing is that you're not on your own with this. There are loads of different open source. I've just realized I started at past, didn't I? I have got loads of time. This is so good. Excellent. Okay, we're going back. Forget what you saw. We're going back. Excellent. Okay. So, but now this means I need to find out why my inventory isn't working. Okay, why isn't inventory working? Anyone spot an issue that I made with this? Yeah, but I should be able to see inventory pop up, but it doesn't. Normally inventory pops up here. But you were right. But normally it pops up. Yeah. Yep. Which call? The curl call? Yeah. Okay, let's try that again. I like this shared pair programming. I'm a fan. Okay, that's not the right terminal. Go to this one. Let's try this again. Let's see what happens. We'll give it a few minutes, a few seconds. Try and refresh, see what happens. No. Okay, what I'm going to do is I'm going to redo the code just in case I accidentally added in a bug somewhere with my missaves. Right, bear with me 2 seconds whilst I put this in. And then hopefully Oh, I'm so glad I had more time. I thought I was totally out of time, overrunning. This is so much nicer. Okay, right. MicroProfile config. I mean, that should just be straightforward. Let's just check the other one. Yeah, that's inventory. That's false. Okay. All right, let's give that curl command another go. Okay, let's see what it does. Hey, okay. I introduced a bug somewhere. I'm sorry about that. Thanks, just a copy and paste, but thank you. So with this, let's do it again. So let's try, hey, there we go. Okay, so we have 3 spans like we're meant to see. So here we can see we've got a HTTP GET request. As I mentioned, that's how we're getting the data from the system microservice. And then we can deep dive into these additional tags as well, understanding sort of what's going on more within that particular trace. So now that we can match the diagrams we see here, and I haven't gone wrong this time, we'll go to the next step, which is about enabling the manual implementation rather than the automatic. So in this, what we're going to be doing is essentially adding that @with span annotation to enable a particular method to be able to customize and sort of further control our traces. We're also going to be utilizing later on, we're going to be injecting a tracer object, again, to have that further customization and control for potential spans that we want. So the first thing we need to do is go into our pom.xml file. And here we're adding 2 dependencies, which I will show you once I've copied. So copy, paste, save, and then, in this, what you'll see, here we go, is we are adding these 2 dependencies, OpenTelemetry and OpenTelemetry Instrumentation. It is important that you do need both in your build path, so do make sure you have both. Now, I'm using Maven in this example. We use Maven in our guides. That doesn't mean you have to. If you want to use Gradle, OpenTelemetry also works with Gradle, or even Ant. I mean, if you really want, your choice. Okay, so the next thing I need to do is edit my server.xml. So we're going to go back into the server.xml. This is for inventory. And here, I'm just going to be adding in something that enables me to be able to essentially expose it as third party. So essentially what I'm adding in here is this line here. So OpenTelemetry APIs are exposed as third-party APIs. So to be able to add the visibility of OpenTelemetry to the application, we need to add third-party to the types of API packages that are supported. To be able to do this, you can, if you want, explicitly list out API packages, but essentially by doing this plus third-party, we're skipping the need to have to list them all out. And essentially this just means that we're adding all third-party to the default list of API package types that are supported. So that's why we're adding this in. Okay, so now we're going to get onto the actual annotation part. So we're going to annotate our inventory microservice. So we're going to go into this class inventory manager. And in here, we're going to be adding this @with span annotation and also the span attribute annotation. So if I go into this and paste it in, what you'll see is for both add and list, I've got this @with span annotation. I'm also using the @span attribute to be able to customize my value to indicate that it's part of the trace. So just to prove that this is definitely live, even though you know, because everything's gone wrong, so I apologize. But let's add in JSpring, because we love it. Okay, so hostname JSpring. So we should see this in Jaeger when we run these later. Okay, so we now need to check out that the traces are generated with the @span annotation. So we're going to run this curl command. Let's just ignore these errors. We're going to run this curl command, and then that should, hopefully, fingers crossed, also show up in Jaeger, if I've done this correctly. Find traces. Yeah, perfect. Okay, so we can see that we have them in here. These are the ones I added in inventory manager list. And now if I run this second curl command, what this will do is essentially check that the information I've generated is from the span attribute. So it is that customization that I provided earlier. So I've now run that. So if I go back to Jaeger and find traces again, perfect. This is all working now. This is fabulous. Okay, so in here, you can see there's my host name, JSpring, because it's obviously for you guys. So you can see that you can start creating customizations by utilizing these annotations effectively, depending on what you need within your application. Further on in the guide, what we also do is we can inject a custom tracer. So to do this, essentially, we are... again, this is for the inventory. I'm not going to do it just because I don't think we've got time, because I want to get onto the resources at the end. But in this, what we're doing is utilizing the @inject annotation. So this is that CDI injection that I talked about earlier. So we're utilizing the @inject to be able to add in a tracer, to be able to create traces again. And again, it just gives you a bit more, if I show the diagram, yeah, so you can see the logs that we add here. Again, adding in that additional customization and being able to see that depending on what you need in your application. With all our guides, we usually run tests. We have a few basic tests that are happening. With dev mode, it's quite easy. All you do is just hit enter, and it will test your application for you. We don't do it on every save, because that would be hella annoying. So we do it only when you click enter, when you want to actually test the application. Right now, we've only got 4 tests, so it's fairly basic. We're just checking the application works. When it comes to actually testing OpenTelemetry, you'll need to look at the visualization. We don't actually have tests to test the observability, if that makes sense. This is just testing that you've not broken the application. So good, it's all passed. But yeah, so that's the guides. This is our cloud native environment. So if you do want to do any of the other guides we have, they're available on OpenLiberty.io and the guide section, and we've got tons of different guides that you can check out. If it has this run in cloud option, that's when you can utilize our cloud native environment. All you need is a browser. So if you've got a particularly locked down machine and you can't download dependencies, for example, this can be a great alternative to just trying out and learning about new technologies. We're quite proud of it, so please let us know if you like it, because we've been working hard on it. So share your feedback. Cool. Okay, so going back to this. So, summary again. As I showed you with my passion and enthusiasm, hopefully what I've shown is increasing complexity, but we have the tools available to be able to enable effective observability through lots of different open source options, including OpenTelemetry and MicroProfile. If you do want to learn more about this, here are some useful links that you can check out. And if you do want to know when that guide that I was showing goes live, you can either follow me or you can follow OpenLiberty on social media. I also run that, so it's basically me twice. So I'll say hi, and I will be sharing when that goes live with everyone on Twitter, LinkedIn, etc. So check that out. Or you can sign up to our RSS feeds on the website. So as I said, I'm going to wait for people. 3, 2, 1. Perfect, you've had your chance. There's also the interactive guides, and these are our observability ones. So if you want to know things like how you can use Zipkin, how you can use Jaeger, how you can enable health reports, for example, or MicroProfile Metrics, like I mentioned, then definitely check these out. You can utilize the cloud native environment if you want to, or you can do it locally, depending on your preferences. Please do connect with us. Let us know what you think if you try any of this out, or you just want to say hi. I'll say hi back. That's fine. We're on LinkedIn and Twitter. So with that, it is now time for me to end. I am on time, thank goodness. So hopefully you enjoyed this. Please do remember to rate the session. If you liked it, I'm Grace. If you didn't, I'll be Brian for today. But yeah, please let me know what you think. And if you have any additional questions that I don't get to answer today, feel free to reach out on Twitter or LinkedIn. Thanks very much, guys.